Hello ladies and gentlemen, welcome back to the Doug Quantum Show. My name is Doug Quantum and today I'll be teaching about the only thing I'm knowledgeable about in the slightest, quantum computing. I'm grossly unqualified to be a news anchor. Now, to understand what makes quantum computers so special, we first need to understand how traditional computers work. Computers work in binary. Everything you do on a computer is a result of a bunch of ones and zeros working together to give you the final result. But it's not actually ones and zeros doing all the heavy lifting. That's just the most common representation of what actually occurs. Processors are made of trillions of tiny transistors. The ones and zeros are representative of what's happening in those transistors. Each one or zero is known as a bit, and the purpose of a transistor is to either let electrons flow or stop flowing through it. This means a zero is when electrons are not flowing, a one is when they are flowing, or any other form of binary representation you would like to put to this process. Now I'm sure you're asking yourself, Doug, how are quantum computers different than the standard ones? And I am sure glad that you asked, seeing as it is the only thing I know about. Before we delve into quantum computing, we must first take a look at quantum mechanics or quantum chemistry. This is the study of the atom and how it moves in space, and this is very important to quantum computing as it is largely based on positioning. In layman's terms, traditional computers run on ones and zeros, while a quantum computing bit can be a 1, 0, or both at the same time. This is possible because quantum computers don't use traditional transistors. Quantum computers use something known as qubits instead of traditional bits. Qubits use spins instead of electrons to process information. Spins are based on position, so it doesn't work on a binary scale. They can be ones, zeros, up, down, and everything in between. This will lead to an exponential increase in computing power. So if quantum computing is so powerful, why don't I have one? And why can't I buy one? Well, there are a number of reasons. For one, they require extremely precise conditions to run. They need to be kept extremely cold, 10 millikelvin to be exact. That's negative 273.14 degrees Celsius or negative 459.652 degrees Fahrenheit. Many households can't do that. In addition to the temperature requirements, they're also extremely sensitive to noise, any temperature change, and just about anything in the environment at large. No home can be as controlled as the lab, so for the foreseeable future, quantum computing will have to remain for scientists only. Mostly. You can use IBM's Watson quantum computer through the cloud by going to their website. You know how traditional machine learning is often stupid and slow? I mean, just look at how dumb it is. Well, quantum computers use a much more efficient model of machine learning known as fault tolerance. A quantum computer's fault tolerance comes from the superposition of qubits. Since qubits basically add on another level of how quantum computers function, they are much more productive in searching for all the possible solutions to a problem. This is in heavy contrast to traditional machine learning, which searches for solutions one step at a time, which can take forever, and also leads to incorrect answers much more often. Once a quantum computer gets a problem wrong, it will cancel out any other scenario in which that incorrect answer is produced again. This method will make it so that more accurate solutions can be given at a much quicker rate. Now you may be thinking, okay, all this is cool and everything, but what could it serve for us? Oh, my naive little child. There's but an endless mirage of possibilities for the future when you look through the eyeballs of a quantum computer. Even though it may not be able to do a whole lot now, quantum computing will revolutionize our lives when it improves. For example, quantum computers will be able to solve problems at an exponentially faster rate, as we discussed with fault tolerance. This will give us access to all new discoveries in technology, such as super advanced and defined simulations of atomic and chemical processes. We may be able to discover new materials down to the molecular structure through these simulations, as well as discover new chemical catalysts. All of this requires more computer power than all computers in the world combined have today. Developing artificial superintelligence may be easier to achieve with the addition of quantum computers involved in research. The possibilities are infinite, beyond question. Okay, I know that was a lot of information to throw at you about something that you may not even care about, but you can't doubt how cool it is. Every day, researchers in quantum computing are making new discoveries and constantly pushing the boundaries of science. Who knows, maybe someday you may have a very cold computer in your home that can automatically calculate the most perfect way to cook eggs over easy. This has been Doug Quantum with the Doug Quantum Show.